37, we're going to tie together all the things you've looked at in Chapter 2. Adding, subtracting, multiplying, and dividing fractions. And the key, of course, is learning when to do what. When do you find the LCD, when do you not? So it's important to do lots of homework. As a general rule, though, I think we'd all rather multiply and divide fractions than add and subtract fractions, right? Because at least when you multiply or divide, you don't have to get the LCD, do you? Anyway, so we'll do lots of problems here. We'll focus on good algebra skills, writing the whole problem down on each step. Before we do that, though, let's answer that question about dividing fractions. Why does that work that way? How come when you divide a fraction by another, you keep the first one the same and multiply it by the reciprocal? Or you could say, how come when you have one fraction over another, how come you keep the top fraction the same and multiply by the reciprocal of the bottom fraction, right? These two things are saying the same thing. Well, here's two reasons. The first reason I got from a Math 60 teacher last year when I was visiting his class, and you'll notice that in your Math 60 class you will occasionally see other Math 60 instructors sitting and observing. We do that because we want to get better at teaching the course, and we learn a lot from each other. And here's one thing I learned from this teacher. So the idea is with division. Let's think about money. Isn't everything always easy when you think about money, or easier? When you have $20 in $5 bills, the question is, how many bills do you have? Well, $20 in $5 bills, if you divide the $20 by the $5 bills, you have a total of 4 bills, right? Makes sense? If you have $20 and it's in $1 bills, how many bills will you have? Well, you have $20 and you have $1 bills, so you have to have 20 bills, right? Okay, that makes sense. What if you have $20 in quarters? In quarters now. So $20 in quarters, you got quite a few quarters there, right? You know how many you have. You have $20 in quarters, so that would be 80 quarters, right? Well, think of it this way. Each item or each piece is worth 1/4 of a dollar. Isn't that what a quarter is? 1/4 of a dollar. So 20 divided by 1/4 has to equal 80, right? So the way you get 80 is you multiply it by the reciprocal of that. So that's a nice way to think of it, I think. Here's another way. Some of you might not like this, some of you might. Here's another reason. Let's go back to the very basic definition of multiplication, the very, very basic one that says when you divide, this is back in chapter 1, when you divide one number by another, like 12 divided by 4 equals 3, it's because 3 times 4 equals 12. Remember how division is a backwards way of multiplying? Okay, well, it turns out you can think of it like this. The reason why this fraction divided by this fraction equals this fraction, okay? It's because when you take this fraction and you multiply it by this fraction, you get this fraction. You see, and the reason why it works that way is because don't the d's cancel and the c's cancel when you do that? So this is nothing more than just the basic definition of division. It's kind of complicated because you have fractions, but it's still saying this first fraction divided by the second one equals the third, because when you take the third and you multiply by the second, you get the first. So it does satisfy that definition. Well, there you go. Anyway, like I was saying, these last couple problem sets are really important. I would say if you can really master the problem sets 36 and 37, you have the whole chapter down, because this incorporates everything you've learned. So we were talking about this. Which would you rather do? Multiply these two fractions or subtract? I think most of us would rather multiply, right? Multiplying is a lot easier than subtracting. Why is that true? It's because when you multiply, you just multiply straight across, right? And then I think the 3's cancel and maybe a 5. I get negative 1/4. But when you subtract, first you got to change the additive form. It's a good idea to do that. Change the minus sign to plus and negative. What's the LCD between 6 and 10? Let's see. I think it's 30. So we have to multiply this on top and bottom by 5. This on top and bottom by 3. So what is 25 over 30 plus negative 9 over 30? I get what is that? 16 over 30, right? But that can be reduced. Don't forget to reduce your answer. When do you reduce? You always look to reduce. You factor the top and bottom and you get 8 over 15. Okay, let's keep on going. How about this one? Look at number 3 here. We're going to multiply this fraction times this one. The order of operations says we do the subtraction first. You got to have the LCD inside here, but you don't have to worry about the LCD here because it's multiplying. So a good first step might be to write the whole problem down, of course, change the minus to additive form. And then what is the LCD going to be inside? Isn't it 6? So multiply this by 3 over 3, and this by 2 over 2. So I get this 2 over 5x just hangs out in the front. You get 9x over 2, or 6 I should say, plus negative 2x over 6. You combine these now, they're common denominators. You get a 7x over 6. Notice how I wrote this 2 over 5x the whole time? Now you're multiplying, so multiply straight across. I think you can cancel something here. Let's see, what can you cancel? An x, and then maybe a 2. So that's why you get 7 over 15 as your answer. I'll do a couple more, then give you some to try. Now in this one, it's kind of interesting. You have a subtraction and division. We do the division first. Now, there's 2 ways to go here. You could leave this as a subtraction, or you could change this to additive form and then do the division. Either way, you do the division first. Let's see. In this case, I did change it to additive form. Sometimes I will, sometimes I won't. But in this one I did. I changed the minus sign to plus and negative. Notice the negative goes on the numerator. I still do the division first. Of course you get the same answer even if you left it as a subtraction. But anyway, flip this over, and then we're going to multiply this straight across. I don't see any reducing, do you? If you could reduce that, you would, but we just get this. Now we have to add, what's the common denominator between 6 and 3? The least common denominator is 6. I multiply top and bottom by 2. So I'm down to here, and then I can add the numerators. I get negative 15 over 6. Negative 15w over 6, right? Are we done? Are we done with this problem? I think we can reduce that, right? You can cancel 3. You get negative 5 halves. Negative 5w over 2, right? There you go. Let's do another one. This one, it's a good idea if you can mention, like, how would you start this? Well, what would your strategy be? It's a division problem, but first you got to do the subtraction. So don't you have to get an LCD here and LCD here? The LCD here is going to be 6, I think. What's the LCD going to be here? 12? I think that's right. So on the first one, here you're going to multiply top and bottom by 3, top and bottom by 2. Here you're going to multiply top and bottom by 3, top and bottom by 2. So what you end up with is you get, let's see, you get 3w, what's 3w over 6? 3w over 6 plus negative 2w over 6. I think that's just 1w over 6, right? Here you get, this becomes a 9. You can't see that well. This is 9w over 12 plus negative 2w over 12. What's 9w plus negative 2w? It's 7w. Whoops. I dropped the w, didn't I? So what should the final answer be? The w's cancel as well. Isn't it just 2 sevenths, I believe? Yeah, it's just 2 sevenths. That's your answer. It's not 2w over 7, it's 2 over 7. That's a common mistake, isn't it, to drop? Okay, why don't you hit the pause button and try these on your own. We'll go over them in just a minute. Okay, here we go. Yeah, these problems are pretty challenging. You really got to put the time in. If you get stuck on a problem, go ahead and just go on with your homework, finish your homework, and then you can always ask that problem in class. Your teacher would be very helpful. Or you can go to the Learning Support Center too, right? All right, so we got a division here. Well, that's good. So we flip over the second one, and then all we have to do is multiply. But when you multiply, you learned that you really want to factor, right? So we're factoring everything. W minus 2 just stays W minus 2, but 12xy becomes 2 times 2 times 3 times x times y. 3x becomes 3 times x. I'm going to put the 3 here. I'd like to put the x over there. And then 2w minus 4, can't you factor out a 2 from there? All right, well, everything's factored. And look, the w minus 2's are going to cancel. They form a common factor. It looks like an x might form a common factor, a 3 and a 2. If you look carefully, everything cancels from the bottom. That means you have a 1 left, and you just have a 2y. That's what I get. All right, this one I think is the hardest one. You got a multiplication here and a division. You do the multiplication before the division, right? Because you go from left to right. However, you want to try to simplify and set the parentheses even before that. That's what the order of operations says. So let's do that. Let's get the common denominator inside the parentheses. Isn't the common denominator 4? So you multiply top and bottom of that by 2. This is 2y over 4 plus xy over 4, so you get this. So that's all I've done. I've just found the common denominator inside the parentheses. Now when we do the multiplication, same story as before, we're not going to really want to multiply this. In fact, we're going to want to start to factor it more. The 4 factors as 2 times 2, right? The 2x plus xy, I think you can take a 2 and a y. Can't you factor a 2 and a y out? That leaves you with 2 plus x inside the parentheses. The 4 is 2 times 2, and you also have a y here. And we still have to divide by 2. But look, when you divide, well, let me do this. Let me reduce first. What can I cancel here? I can cancel a 2. I can cancel another 2, a y. So all you have left is 2 times 2 plus x. And then when you divide by 1/2, the same thing as multiplying by 2. So on the top, you just get another factor of 2. So like I said, this is kind of a lot of work. So you get this. You could leave it like 4 times the quantity 2 plus x, or if you multiply it out, you get 8 plus 4x. Phew. All right, here we go. This one isn't too bad. It's got some sneakiness to it. That minus sign is very tricky because the minus sign, when you change it to plus and negative, the negative sign governs the whole numerator. So there's really parentheses around the whole numerator. So you have to get a common denominator. What is it? What is the common denominator going to be here? I believe it's going to be 9. So you multiply this by 3 over 3. That's why you get 6x over 9. And then when you distribute the negative sign, you get plus negative 3x plus negative 4 over 9. When you add these numerators, you can only combine like terms. So the 6x and the negative 3x becomes 3x. And this becomes 3x minus 4 over 9. That's all you can do. One more. This one, what would you do first here on this last one? Let's see, you do the division first. Now, you could change the minus to plus and negative. In this particular one, I didn't. Previously, I did. They're both just as good. You know, my advice is probably pick a method and learn it really well. But you should recognize that they're both different ways to do it. So if you leave this as a minus sign, we're going to get the same answer. Flip this one over, change it to a multiplication. Then what we do is we're going to factor everything. You get 3 times 2 on the top, 2 times 2 times 2 times 5 times x on the bottom. We can cancel a 3, no, just a 2, I think. So that's why you get 3 over 20x over here. So this is where we're at. You get 3 over 4x minus 3 over 20x. We changed to additive form at this case. Yeah, now I changed to additive form. You don't have to, but I did right there because it's getting kind of tricky. Multiply top and bottom by 5. Isn't that your LCD, 20x? So you get this. And then, let's see, when you add this together, you get this. Are we done? Is that your final answer? 12 over 20x? Can we reduce that? Well, yes, we can. Always look to reduce. 12 is 2 times 2 times 3. 20x is 2 times 5 times x. You can cancel a 2. You can cancel 2 2. Your answer is 3 over 5x. And we're done. We'll see you next time. Bye-bye.